Hello everyone, and today we are looking at an O-level question on matrices. So let's jump right in. Let's read the question. A shop sells two types of t-shirts, dry fit and cotton shirts. Each type is sold in three different sizes, small, medium, large, okay? And the sales in two successive weeks. Successive means consecutive, like one after another, and they're given in the table below. So you can see right here, we have the first week. So really, you know what I'm going to do? I'm just going to like highlight this because this is the first week. This table is for first week. And then we have second week over here. And yes, the two tables are combined, but they really are representing different weeks. And then of course, we have, of course over here, we have one row for dry fit, one row for cotton. So that's kind of how we look at the table. And the information for the first week's sale can be represented by the matrix C equals to, and then you can take a look over there, right? And you can see really it looks very similar to how the data is represented here, right? 7, 26, 11, 7, 26, 11, 12, 30, 16, 12, 30, 16. And then they tell you the information for the second week is represented by matrix D, and so really we just have to take, for the second week, just take this and represent it in a very similar fashion. So actually, you know what, I'm just going to straight away write it in the answer space, like this. There you go. Alright, and then let's move on to part B. Given that F equals to this matrix, so don't be frightened when you just see a new matrix. It's okay, like, okay, they give you a new matrix, sure, and they give you this relationship, S equals to C times F, and they ask you to calculate S, okay, and they ask you to what is represented by the elements in S. And so, you know what, let's just calculate S first, and so I like to just write it down so that it's clear to me. S equals to CF, and what is S? We don't know, we're trying to calculate it. What is C? Okay, then we look at the question again. C is this, right? So let's write it down. Like this is C, this is the matrix. What is F? This is F. So, right. And then, right now we can see over here that, let's look at matrix multiplication and let's revise a little bit here. And over here, this is 2 rows and 3 columns. And this is 3 rows and 1 column. And so the order of the matrix, or the matrices, is 2 times 3. And this is 3 times 1. And you can see that, yes, you can multiply them because these two inner numbers, if you would, are the same. And that's the requirement for multiplication to be possible. That means this 3, which is the number of columns of the first matrix, must be the same as the number of rows of the second matrix. Okay? And so, of course, the two inner numbers, if you would, disappear. And what is left is 2 and 1, which means, let me just write it this way. Usually I would write it below over here, but for the sake of space, I'm just going to write it over here, write it big. So this will be a 2 by 1 matrix. That means over here, there'll be 2 rows, and this will be 1 column. That means there should be 1 thing here and 1 thing here, right? 2 rows, 1 column. So what goes in the top? And then so let's look what goes in the top. It's important to note that we first go for this first row. You can see that this is row 1 and row 2. So row 1 with, there's only 1 column we have. So row 1, column 1. So we see here, this is the first row, right? And of course the only column. So we see, we take 7 multiplied by 1 plus 26 multiplied by 1 plus 11 multiplied by 1 and write it down. So this will be, you take the first row, in the first column, 7 times 1, plus 26 times 1, plus 11 times 1. So if that went by quickly, let's go back and watch that part. Make sure you really see how this row is kind of transported with, to kind of be multiplied with this column. You can take a look. And then, right now, we see that this is the, now we have the second row, and of course, we only have one column. So we look at the second row, and of course, only one column. And then we see that it will be 12 times 1 plus 30 times 1 plus 16 times 1. And then, if you simplify this, this will give you 44 and 58. So let me write it down. There you go. Okay, so now let's see. It says describe what is represented by the elements in S. And so really, I think the easiest way to do these kind of questions is look at the working. If you look at the final answer, it's kind of hard. But if you look at the working, it really tells you often that like what is really represented by the elements. So what do you do here? You took 7, really you got 7 plus 26 plus 11, and what is that? What is that? 7 plus 26 plus 11 is the total number of dry fit shirts that was sold in the first week. Total number of dry fit shirts that was sold in the first week, right? And then you see the second element over here. What do we have? We have 12 plus 30 plus 16, and what is it? Then you see again, this is 12 plus 30 plus 16, which is, you add all of them, is the total number of cotton shirts sold in the first week. So we can word our answer this way. They represent the total number of dry fit shirts and cotton shirts sold. Respectively in the first week. So the word respectively tells me that it's the total number of dry fit shirts, cotton shirts, but it's one after another. Like I'm telling you the dry fit shirts one first, which is 44, followed by the cotton shirts one, which is 58. And then of course, but both of course are in the first week. So I put that at the end. Okay. Let me just zoom out so you can take a look holistically at the working. Feel free to pause. Yeah. Okay, and so let's move on to the last part. The last part says given that G equals to this matrix and Q equals to GS, they want us to calculate Q. So in similar fashion, I write down the equation that they gave us, the formula, and we want to calculate Q. So I don't know what Q is, so I'll leave it there, and then say 1, 1. And S, what is S? I don't know, I forgot what S is. Oh, S is what I calculated over here, 44 and 58. So, 44, 58. And immediately you can see this is a 1 by 2 matrix, and this is a 2 by 1 matrix. So these two kind of disappear. What is left will be a 1 by 1 matrix. So one row, one column, there's only one thing that's going to be inside. Okay, and so let's calculate this. So it's going to be 1 times 44 plus 1 times 58, which is equal 102. 102. Done. Only one thing. What is represented by the elements? Same thing. Look at the working. We took 44 plus 58, and what is that? What was 44? 44 was, if you remember, it was the total number of dry fit shirts, right? And 58 was the total number of cotton shirts that was sold in the first week. And if you add both of them up, oh, it's the total number of shirts sold in the first week. It's just the total number, dry fit and cotton all together. So you can write down it is, or maybe let's put a full sentence. It represents the total number of shirts sold in the first week. Voila. So I'll zoom out so you can look. This is the total, this is the full question.